On this question, I actually struggled quite a bit to figure this out. I made a kind of a mistake I'm going to bet a lot of you make. So we've got somebody who runs a 1 meter dash, and this is the key information. For the first 1 second, they go from, so the same way this is, V1 equals 0, and V2 equals 5.4 meters per second. And this is over a time interval of 1 second. And so what you want to do is calculate the amount of energy that they have. Now notice they did not give the mass, is not given. So what's up with that? Well, kinetic energy, you know, is 1/2 mv squared. So what I like you to do is just assume the mass is a 1 kilogram. You can choose 10 if you want. The m's will ultimately cancel because you're going to do a ratio here. The ratio is the kind of the question. So this is for the first 1 seconds, from 0 to 1 seconds. For 1.0 to 1.5 seconds, you have to calculate the difference. So he's traveling, you've got the kinetic energy at the beginning, which is 1/2 mv squared, where the v squared is 5.4. And then you've got the kinetic energy at the end, which is 1/2 mv squared, where the v is now 9.8 meters per second, right? And so what you're going to do is find the total energy here, and then the total energy here, and subtract. Do not, the mistake I made is I subtracted 9.8 minus 5.4, but because you're squaring it, the math, it's bad math. So find what this energy is. You're going to have a number here. It's a big number, right? And you're going to have a smaller number here, and you're going to subtract them. And that is the energy in this system. Okay, and then to do the ratio, you will take, and it asks you in the problem to do the p from 0 to 1 divided by the p from 1.5 to, or 1.0 to 2.5. As a note, this is, one thing I didn't say, I guess, is when you're doing, this is the kinetic energy, it's actually the power, you would divide by the time. So once you find the power, you subtract, divide by the time. In this case, the time is only 1 second. So the energy and the power are the same. But this one is not 1 second. You're going from 1 second to 2.5 seconds. So that's 1.5 seconds. And then that's the powers that you're going to divide when you do these. And then the second half, of course, which intervals is the power output greater? Well, I think you can figure that out because it'll be obvious which number, is this number bigger or is this number bigger? And that's how you'll solve that problem.